Hello, everyone. So today we'll be focusing on enhancing the quality service for real-time application in computer networks. So our overview for this video is that we'll be focusing on what a quality of service is and its importance, some background information related work, problems related to this service, and proposed methodology, conclusion, reference. So what is QoS? QoS is basically the quality of service, and it's important on network because it works on network to control traffic and it ensures the performance of critical application within the limited network. So it helps adjust the network traffic by prioritizing specific high performance application. Quality of service is important because it helps in reducing latency. So an application without quality of service means that the network performance is less reliable. Because without quality of service, the data in the network will be disorganized, bottlenecks will happen, and performance issue arises, which will cause poor network performance. So the quality of service can also be used in optimizing the network resources, like prioritizing traffic based on its importance and requirements. It also makes sure that the needed real-time applications receive the necessary bandwidth and resources by preventing congestion and bottlenecks in the network. So here are some of the common applications where the quality of service is used. So the most famous ones are video conferencing platforms like Zoom, Teams, WebEx, and other types of video conferencing tools. They all use quality of service to provide clear audio and video communication, making sure that there is a smooth experience for users. Another major service, which is regular in our day-to-day life, are Netflix, YouTube, Hulu, Amazon Prime, and other types of streaming services use quality of service to deliver consistent and high-quality network performance to provide buffer-free streaming. So in this video, we'll be mainly focusing on quality of service and its benefits and how it can enhance the service for real-time application networks. We will focus on the article, Dynamic Adaptation Policy to Improve Quality of Service in Real Time. So in this article, we'll be reflecting on the findings regarding the topic. The main goal of this research project is to build upon and improve the findings reported in the reference paper by authors by addressing the difficulties related to quality of service in computer networks. So the background information related work. So the article we chose to read for this project is the Dynamic Adaptation Policy to Improve Quality of Service in Real-Time Multimedia Application in IEEE 802.11e WLAN Network. This article focused on challenges and proposed a solution for improving the quality of service in real-time multimedia application. The research paper focused on real-time multimedia application like video streaming, voice calls, and interactive media, which often require low latency and consistent performance. It mentions that the wireless networks can pose challenge like varying in signal strength, interference, and limited bandwidth, impacting the quality of service for multimedia application. The author proposes a dynamic adaptation policy as a solution to improve quality of service. The dynamic adaptation suggests that the system can adjust its parameters or configurations in real time based on network condition and application requirements. So we'll go to the problem statement now.
So the challenges faced by real-time multimedia applications within IEEE 802.11e LAN network includes the issues related to high latency, packet loss, and variation in the network condition that affect the QoS provided to real-time multimedia applications. Some of the problems associated with the solutions are adaptation latency. So the time it takes for adaptation mechanisms to detect changes in network conditions and implement adjustments can introduce latency. This can have a major impact on the user experience while using real-time applications. Further, there's issues with network dynamics, as the dynamic adaptation relies on accurate and timely information about the network conditions. Further, issues regarding scalability. As the size and complexity of the networks increases, the scalability definitely becomes a concern. A few of the shortcomings include resource constraints. So the resources needed to support dynamic adaptation mechanisms may be limited, and the user experience is also impacted, as constant adjustments to QoS parameters can impact the user experience, especially if the adaptation are noticeable or introduce artifacts in multimedia content. Our proposed methodology. So the objective is to elevate the quality of service for multimedia applications. This can be achieved by implementing traffic prioritization using protocols like differentiated service or IEEE 802.1p for Ethernet networks. By assigning higher priority to multimedia flows, particularly real-time audio and video streams like FaceTime, this system can effectively reduce latency. This prioritization ensures that critical data experiences minimal delays during processing and transmission. The protocols employed in the traffic prioritization guarantees that high priority traffic receives significant treatment in terms of bandwidth allocation. Implementing this not only enhances the overall user experience for multimedia applications, but also efficiently manages network resources, ensuring consistent quality of service for critical applications in various network conditions. So another solution is network slicing, which involves creating separate network on a shared physical infrastructure. And each slice or part is assigned or used to specific applications, and it allows for the customization of network resources, policies, and functionalities. Some of the expected results of the service is that its service providers can offer customization multimedia service with specific quality of service characteristics narrowed to the needs of diverse applications or user preferences, which provides reliable quality of service across different application platforms. Like such as video conferencing and real-time communication can coexist within the same network infrastructure, each benefiting from dedicated resources and quality of service guarantees. So some of the shortcomings of our proposed solution is that while implementing these strategies, we also have to pay attention to certain characteristics of multimedia application, like the network architecture and the devices that are involved during the process. So our conclusion for this project is some of the key concepts that we've learned from this article is that the concept of dynamic adaptation policies and how they're designed to improve the quality of service for real-time multimedia applications. The future for this project is that that can be done to enhance the quality of service for multimedia real-time application is by exploring a way to address the evolving challenges and improve the overall user experience while using certain applications for multimedia service. And another future work would be to research about the integration of edge computing with multimedia applications to reduce latency and enhance real-time processing. So, and this is the reference for our entire project. Thank you.
Thank you.